All right, so we're going to begin page 3. This time we're starting 21, 22. They've given us a square. The square is the most specific of all of our polygons, all the quadrilaterals. And so we've got the sides are all the same. The angles are going to be, we've got right angles everywhere. We've got angles bisected, so you got 45, 45, 90s. You got right angles in the middle. Your diagonals are congruent. So again, make sure you look at all of that stuff, but everything comes into play when we've got those squares. So if A to C, whole thing, if this guy is 26, we're supposed to find B to C, this one. So in a square, again, we just talked about, let's go ahead, look at that triangle, right? If we've got this triangle over here, remember that that side's a right angle. All of these are the same, and so I can use a Pythagorean theorem. If you remember your 45, 45, 90s, you absolutely can use those. But again, your direction said you're allowed to round, so you don't have to. So in this case, x squared plus x squared would be equal to 26 squared. That's the longest side. That's going to be the hypotenuse. So 2x squared is going to be equal to 26 squared, which is something I don't know off the top of my head, 676. And then we will cut that in half. Remember that we absolutely need to follow order of operations. So x squared is going to be equal to 338. And then if we go ahead and take a square root on both sides, x, which was really my side length B to C, that should be an 18 point, and again, as we look at this, right, it would be 18.38. We look at the 8, right, it's bigger than 5, so this would round up to 18.4. That would be my side length. All right, as we look at 22, if the measure of angle A to C to B, so this guy right here, that one is going to be 11x minus 32. We're supposed to find the value of x. So what we're going to remember, right, again, we can even use the triangle that we drew for 21. We know that this is a right angle. These sides are going to be the same, right? And if those are the same, then you have the base angle theorem, right? If this is 90, these two are the same, then they're both got to be a 45. So 11x minus 32 has to be equal to 45 degrees. You could also have thought about it, if that angle is 90, we know that the diagonals bisect, and so each side would have to be 45. So you've got a couple different ways that you could have approached how to set the problem up. All right, 11x is going to be equal to 77, and so if we divide, x should be 7. All right, as we look at 23, the vertices of your quadrilateral, and they went ahead, again, they stuck them on a graph just for reference so that you could see them. Using the distance formula, again, or slope is how we'll say on your quiz. You may use either. Determine the most precise classification. And now you've got to choose between all of these. All right, so ladies and gentlemen, when you start these, you can either do distance or slope. So I appreciate the problem said distance, but we can do either on this. So I'm going to go ahead and start with slopes. Again, on your quiz, you want to be sure that you're labeling everything, and then I'm going to go ahead. There's no way I'm going to fit all this on that piece of paper, so I'm going to go ahead and we'll just put it on the back of this one. Yeah, you can still see that. All right, so ladies and gentlemen, I would go ahead and I would start with slopes. You can absolutely do distance. And again, when you think back to when you did the formative, right? So you could absolutely do distance formulas to prove if the sides were the same, and then take a look at diagonals. All right, so we could do this a couple different ways. So if I want to go ahead and find the slope of L to P, all right, so here's L to P. So I would have 7 minus negative 3 over, since I started with L on top, I'm going to start there on the bottom. Negative 1 minus 3. So I'm really going to get 10 over negative 4, which will reduce down to negative 5 halves. And then I'm going to check the side opposite, right? So L to P is across from M to N. So I'm going to go ahead and check that next, because if they're not parallel, you can be done. It's a quadrilateral, that's it. All right, so M to N, I would have 9 minus negative 1 over, again, I started with M for the Y's, so I'm going to start there for the X's. So 4 minus 8, so we're going to get 10 over negative 4, and so we've just shown that one set of sides is parallel, right? So we know right now that these guys are parallel. So now we got to keep going. So we'll find the slope of, and I'll start with L to M. Again, doesn't matter. Here's L to M. I'm going to go ahead and start with M. 9 minus 7 over 4 minus negative 1. So we're going to get 2 over positive 5. And then we'll find the slope of p to n. And that one is going to be, sorry, had a moment. Here we go. Negative 3 minus negative 1 over 3 minus 8. I apologize. Again, I'm having a brain fart. Here we go. Negative 2 over negative 5, which is also going to be positive 2/5. All right, so ladies and gentlemen, what we have shown at this point, all right, we absolutely have that opposite sides are parallel. So if we look at these two slopes, I know that both sets of sides are parallel. So the next thing, at that point, okay, we absolutely know that it's one of them. So then we're going to look for right angles. So as we look at this, right, I've got a negative 5/2 and a positive 2/5. Well, those are opposite reciprocals, right? If I flip 2 over 5, or 5 over 2, I would get 2 over 5. This one's negative, this one's positive. So at this juncture, we know that opposite sides opposite sides, let's try that again. Opposite sides are parallel. We know that consecutive sides just means the one right after the other. Consecutive. Which means we have right angles. All right, so at this point, what we've decided is that one of these shapes, right, we're down to either the square, sorry, I'm trying to move the paper up. We're down to either the square or the rectangle. This is what we know at this point, right? It's either going to be a square or it's going to be a rectangle. So now it's your choice. Somehow you have to prove that. So you can either do distance formula and show that your sides are the same. You could do that. You could check the diagonals and see if the slopes of the diagonals were perpendicular, right? In a square, the diagonals have to make a right angle, whereas in a rectangle, they don't. So again, if we're trying to avoid the distance formula, we could absolutely do that. Your choice. So I might choose, if we look at our picture, right, I might choose to go ahead and find the slopes of the diagonals. So if I wanted to find the slope of L to N, well, sorry, I gotta move it back down so you can see the points again. There it is. So if I want to find slope of L to N, I would have 7 minus negative 1 over negative 1 minus 8. So that would give us a positive 8 over, looks like negative 9. All right, and then I'm going to do the same thing I'm going to find the slope of P to M. P to M, that would be these guys. So 9 minus negative 3 over 4 minus 3. And that looks like it's going to be a 12 over 1. So it appears, right, the slopes have nothing in common. Right, these are clearly, they are not going to be perpendicular to each other, right? These are not the same angles, they are not opposite reciprocals. And so therefore, again, our choices were square or rectangle. It's going to be a rectangle, right? So rectangle, because diagonals are not perpendicular. So we have no right angles. Again, we could have gone about this a lot of different ways. I think slope is a little bit faster, so that's why I chose to do slope. But if you had wanted to do the distance formula, you could have done the same thing. So if you'd done distance formula, you would have found, just so that you kind of talk through it, you would have found that L to M should have come out to the square root of 29. And P to N would also have come out to the square root of 29. So if you had done distance formulas, just so you can check your answers, if you had done L to P, you would have found that that would have come out to the square root of 116, and M to N would have been 116. So if you'd done distance formula, you would have known right away that opposite sides were congruent, which would have said that you had a parallelogram or a rectangle. If you had done distance formula first, what you would have found right away, it could not be the rhombus and it could not be the square because all your sides weren't the same. So then it would be your choice again, right? So then you're going to look at I think you have to do your diagonals. You can't use your slope at this point because neither one of them would have had perpendicular. So you would have to test to see whether the diagonals were congruent. And so when you look at those, if you had found the diagonals distance, so if you looked at L to N, that should have come out to the same thing as M to P. And both of those diagonals should have come out to 145. And so since your diagonals were congruent, you also would have wound up with a rectangle. So whichever method you used would be fine. You just need to make sure that you've got all your work and you've labeled it for that quiz tomorrow. All right, if we look then, we'll finish out the page here. So if we take a look down at 24 and 25, 24, we have WXZY is a quadrilateral with W here and X is at 3, 0. What must be the slope of ZY in order for it to be a parallelogram? All right, well, here's W, which is at -5, 2, and X is going to be at 3, 0. All right, well, again, if it's a parallelogram, these sides have to have the same slope. So it's really a fancy way of asking us, what's the slope of W to X? So slope of WX, again, Y's, so 2 minus 0 over X's, -5 minus 3. Again, doesn't matter which point you start with, you just have to be consistent. So if I chose to start with W on the top, I have to start with W on the bottom. So I'm going to get 2 over -8, which would reduce down to -1 over 4, excuse me. So our answer should be D. Again, if it's a parallelogram, opposite sides have to have the same slope. All right, as we look at 25, they gave us a rhombus this time. If the slope of F to C is 5 halves, right, so here's our slope, what is the slope of C to D in order for it to be a square? Right? So if I want a square, that means I have to create a right angle, which means that consecutive sides have to be perpendicular. So if my original slope was 5 halves, then my perpendicular slope, I flip it, and I'm going to get a 2/5. If that was positive, then this one is negative. So to create a square from a rhombus, I have to prove that my sides are going to be perpendicular, and so that should be choice B. All right, and then at the bottom of the paper, let me move the camera down so we can see that. There we go. The shape shown, we're going to notice that we've got these parallel symbols. Again, those are parallel, not congruent. I appreciate they're a little small, but those are those arrows. So what we have is a trapezoid, and not even isosceles because I don't have any marking on those legs. They've asked me to find angle P. So we're going to think back. Parallel lines cut by a transversal. Both of those angles are same side interior. So same side interior with supplementary. 7x plus 31 plus 21x minus 19 has to be equal to 180 degrees. And then you're back to your algebra. 28x 31 minus 19 is going to give us a 12. That's got to equal 180. So we'll subtract. 28x is going to be equal to a 168. And then we'll go ahead and divide. And so x should come out to 6, which again, it's a very good answer, but you are a very good student and you're going to go back and make sure that you answered what was asked. They wanted you to find the measure of angle P, so we need to substitute 21 multiplied by x minus a 19. All right, so 21 times 6 minus 19 should come out to 107 degrees. All right, so one more page. If you need help on the back, go ahead, watch that last video.